Welcome to learn algorithm design and analysis. In this session, we focus on how to construct the KMP flowchart for the given pattern. In the previous session, we have focused on how to construct the KMP flowchart. Based on that example, right, we have designed the algorithm KMP flowchart. The algorithm takes the parameters P, M, fail. P is the pattern array and M is the length of the pattern. Fail indicates the failure array. Fail of 1 has been set to 0. For the remaining pattern characters, for K ranges from 2 to M, we have identified or computed the failure links by finding the repetition of pattern characters in the same array itself. Now let's see one example so that we can see how to construct the failure links and how to construct the successful links so that we can check if the given pattern is available in the text or not with the help of KMP flowchart construction algorithm. Now let's take the problem. Construct the KMP flowchart. Construct the KMP flowchart for the pattern AB, CB. Let AB, CB, this is the given pattern. Pattern P is AB, CB. This is the pattern. Given this pattern, we need to construct the equivalent KMP flowchart. The first step is we need to fix the successful links. To fix the successful links, we need to take the pattern characters as the corresponding nodes. So here node values are A, then A to B, then A to B, AB, then C, B. Last node is the termination character star. Initial node is to read the next text character. So here let's write get next text character. This is the initial node. Pattern characters are mapped with the corresponding nodes, say AB, CB. For our convenience, here we can represent the node numbering. This is 0. Let's write here because we need to mark the failure links also, right? Let's mark here 0, 1, 2, 3, 4, 5, 6. These are the corresponding node numbers. First we need to mark the successful links. A to B, right? This is successful link. B to A, then A to B, B to C, C to B, then B to star. These are the successful links. This is step number 1. Then we need to trace the algorithm to find out the failure links, so that after the construction of the failure links, we need to represent the same in this diagrammatic representation so that we will get the equivalent KMP flowchart. Now let's see. We are going to trace the KMP flowchart construction algorithm. In the KMP flowchart construction algorithm, we are passing the parameters. The parameters that we are passing are P, M, file. P is the pattern array. M represents the length of the pattern. Fail is the failure array. Failure array values will be filled after the complete execution of the KMP flowchart construction algorithm. First, we need to trace. So setting fail of 1 to 0. Fail of 1 is set to 0. Then we need to find the failure links for k is equal to 2 to m do. Since in our example pattern is p is equal to ab, ab, cb, length of the pattern is 6. So m is 6. Here k ranges from 2 to 6. We need to find the failure links. Let's trace the algorithm for k is equal to 2 to m do. Initially k is equal to 2. When k is equal to 2, we need to check s is equal to fail of k minus 1. So let us construct the columns so that we can easily do the trace. S is equal to fail of k minus 1. S is equal to fail of k minus 1. Since k is 2, 2 minus 1, 1. Fail of 1. Fail of 1 is 0. S is 0. Then we need to check if S is greater than or equal to 1. S is greater than or equal to 1, right? Condition is false. If S greater than or equal to 1, while S is greater than or equal to 1, we need to execute the if as well as assignment statements. If the condition becomes false, control comes out of while loop, then it executes fail of k is equal to s plus 1. Anyhow, right, let's write the conditional test if s is greater than or equal to 1. Then check if ps is greater than or equal to pk minus 1. Writing here ps is equal to pk minus 1 question mark. Now this will not get executed. Then s is equal to fail of s. S is equal to fail of s. This will not get executed. Then next statement is fail of k is equal to s plus 1. Fail of k is equal to s plus 1. Fail of k, this is equal to s plus 1. Now s greater than or equal to 1 condition becomes false. So fail of k is s plus 1. Fail of k is fail of 2. 2 is s plus 1. S is right 0. 0 plus 1, 1. So fail of 2 is computed. Then to compute fail of 3, k is equal to 3. S is equal to fail of k minus 1. K is 3. 3 minus 1, 2. Fail of 2. Fail of 2 is 1. Checking if s is greater than or equal to 1. Condition is true. Then check if ps is equal to pk minus 1. ps is p1. pk minus 1. pk minus 1 is k is 3. p1 is equal to p2. Now our pattern is, what is the pattern? Let's write here. This is AB, AB, CB. Checking if P1 is equal to P2, condition becomes false. So if PS is PK minus 1, then break. If the condition is false, then it executes S is equal to break. This will not get executed. Then S is equal to a fail of S. S gets updated. Fail of S. Current S is 1. Fail of 1 is 0. S is updated to 0. Then it checks if S is greater than or equal to 1. Current S greater than or equal to 1. Condition is false. So then it executes fail of k is equal to s plus 1. Current S is 0. 0 plus 1, 1. So fail of 3 is also set to a value 1. Then fail of 4. S is equal to fail of k minus 1. K is 3. K is 4. Sorry, k is 4. 4 minus 1, 3. Fail of 3. Fail of 3 is 1. Fail of 3 is 1. Checking if S is greater than or equal to 1. Condition is true. Now check the pattern characters PS and PK minus 1. What is PS? PS is P1. is equal to pk minus 1. Pk minus 1 is 3. Checking if P1 and P3 are equal, right? Yes. If PS is equal to Pk minus 1, then break. Now execute. Break. Break forces the control to come out of while loop. Then this will not get executed. Fail of k is equal to s plus 1. Fail of k 4, that is current s. Current s is 1. 1 plus 1 2. So fail of 4 is set to a value 2. Then fail of 5. S is equal to fail of k minus 1, that is fail of 4. Fail of 4 is 2. Checking if 2 greater than or equal to 1. Condition is true. PS is equal to pk minus 1. P2, this is equal to pk minus 1. P2 is equal to P4. P2 is B. P4 is B. Condition is true. If the condition is true, execute break. Then fail of k is equal to s plus 1. Current s is 2. 2 plus 1. 3 is set to fail of 5. Then fail of 6. S is equal to fail of k minus 1. K is 6. 6 minus 1 5. Fail of 5. Fail of 5 is 3. Now s greater than or equal to 1. 3 greater than or equal to 1. Condition is true. Checking if PS is equal to pk minus 1. PS is P3 is equal to pk minus 1. P5. P3 and P5. P1, P2, P3, P4, P5. Right? A and C. The characters are not equal. If the condition fails, then S is equal to fail of S. S is equal to fail of S. S gets updated. S is fail of 3. Fail of 3 is 1. So S is updated to 1. Then checking if 1 greater than or equal to 1. Condition is true. Checking PS. PS is P1 is equal to pk minus 1. P1 is equal to P5. P1 A. P2, P3, P4, P5. That is C. Condition false. Break will not be executed. S is equal to fail of S. Current S is 1. Fail of 1. Fail of 1 is 0. Then 0 greater than or equal to 1. Right? Condition false. 0 greater than or equal to 1. Condition false. So control comes out of the while loop. Then it executes. Fail of k is equal to s plus 1. Current s is 0. 0 plus 1. This is 1. These are the corresponding failure links generated by the KMP flowchart construction algorithm. Now what we have to do, we need to construct the equivalent failure links in the diagrammatic representation. Have a look into this diagrammatic representation. This one. We need to fill the failure array values. So let me write the diagrammatic representation again here as a part of step 2. Pattern characters are A, B, A, B, AB, AB, then CB. Right? Pattern is AB, AB, CB. Initially, we need to use the node to get next text character. Then mark the successful links here. A to B, successful link. B to A, successful link. A to B, successful link. B to C, successful link. C to B, successful link. B to star, successful link. The failure links are computed using KMP flowchart construction algorithm. That should be updated in this flowchart now. Fail of 1 is 0. So marking the nodes, right, in terms of numbers, 0, this is 0, first node, this is 0, this is 1, 2, 3, 4, 5, 6. First fail of 1 is 0. This should be represented in the diagrammatic representation. Fail of 1. This is a node to read the next text character. So fail of 1. This should be indicated like this, F. So when there is a failure occurs at node 1, we need to go to read next text character. Fail of 1 is 0. Then fail of 2. Fail of 2 is 1. Fail of 2. Fail of 2 is 1. Let me represent like this. This is a failure link. Then fail of 3 is also 1. Fail of 3. 3 is 1. I represent like this. Fail. Fail of 3 is 1. Then fail of 4 is 2. Fail of 4, this is 2. Fail of 4, let's represent without clash here. This is F. Fail of 4 is a 2. Then fail of 5 is a 3. Fail of 5, yes, this one. Fail of 5 is 3, right? Okay. Then a fail of 6 is 1. Fail of 6, 1. We need to mark like this. Fail of 6. Fail of 6 is the node number 1. Okay, this one. This is F. Now this is the KMP flowchart construction algorithm for, this is the KMP flowchart construction, right? Upon the execution of the flowchart construction for the given pattern AB, AB, CB, right? Now let's write the figure KMP flowchart for the pattern AB, AB, CB. So for the pattern AB, AB, CB, we have identified the successful links in step number 1. This is step number 1. Then we have executed the KMP flowchart construction algorithm, KMP setup algorithm. Then in the second step, we have marked the failure links in the diagrammatic representation so that we have easily follow the failure nodes. Fail of 1 as 0, right? Fail of 2, fail of 3, 1. Fail of 2 is 1. Fail of 3 is 1. Fail of 4 is 2. 5 is 3. Fail of 4. 4 is 2. Fail of 5 is 3. Then fail of 6 is 1. So once this KMP flowchart has been constructed, we can easily scan the pattern in any given text. That means whatever is the text value for the pattern, KMP flowchart is constructed only once. So once the flowchart is constructed, it can be used to check if it is available in any of the text. So whatever is a text value, the flowchart construction is the common one so that we can find if the pattern is available in the text or not. Now let's take one text so that we can check if the pattern is available in the text or not. Now let's take the text value. Text value is a T array. Let's define a T as AC, AB, AA, BA, BA. Let's have a text value as AC, AB, AA, BA, BA, and having the pattern P as AB, AB, CB. Now the problem is we need to check if the pattern P is completely available in the text T or not. For that we are going to use this KMP flowchart construction algorithm. Let's fix the column so that we can easily do the trace. Let's fix the columns. KMP cell number, then text being scanned. In this column we have two subcolumns. One is the index and another one is the character. Then write success or failure and follow the corresponding links, success or a failure. Text is AC, AB, AA, BA, BA. It takes 2 pages. So let me write in the next page also the table header KMP cell number, then text index, then equivalent character, then last column that determines the success or failure, and we need to execute that step. Now let's start KMP cell number 1 onwards. Now currently we are in a KMP cell number 1. KMP cell number, this is 1. KMP cell number is 1. Text index, right? Let's mark the text index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 characters in the text array. Starting from pattern characters, say 1, 2, 3, 4, 5, 6. Text index is 1. At index 1, we have a character A. Then the character A, right? This matches with the pattern character. That means at cell number 1, right? Have a look into this diagrammatic representation. At cell number 1, we have a character A, right? So there is a match. At cell number 1, we have a character A. So success or failure, we need to mark success. At cell number 1, if we have a success, we need to move to cell number 2, right? So write cell number 2 in the next stage. KMP cell number is 2. Then the text index should be incremented by 1 during the success. Text index is 2. At the second index, the character available is C, A, C. Now at cell number 2, we need to check if there is a character C. At cell number 2, right, from the diagram, we have a character B, not C. So at cell number 2, character C is not available. We have got a failure 1. At cell number 2, the control is now transferred to the corresponding failure link. At cell number 2, cell number 2 here, if there is a failure, control is transferred to cell number 1. So in the next step, KMP cell number is changed to 1. At cell number 1, right? Next, we need to take the same text character. Index is 2, character is C. At cell number 1, right? We need to check if the character C is available. It's not C. So again, we have got a failure 1. At cell number 1, we got failure. So we need to read the next text character at cell number 0. So write cell number 0 here, then 2C get next character. So next cell number becomes 1. Text index is incremented by 1, 1, 3. At the third index, right, in this text array, we have a character A, 1, 3, A. At cell number 1, we have a character A, so success, that is moved to cell number 2. So success, then cell number here 2, then index is incremented, 3 plus 1, 4. Pattern character, text character is at 4th index. We have a character B. At cell number 2, check if the character B is there. At cell number 2, yes, the pattern character B is there. So here again, we have got success. Then cell number 2, this is changed to cell number 3. Index is right, incremented by 1, 5th one. 5th character is here A. At cell number 3, check the character A is available. Yes, at cell number 3, the character A is available. So again, right, this results in a success. Then next stage, cell number 3, we have got success. So let's write in the next page. Cell number 3 got success. So KMP cell number is changed to cell number 4. Next index is incremented, 5 becomes here 6. At the 6th index, we have a character A. 6th index, we have a character A. Now check if the KMP cell number 4 has a value capital A. Cell number 4 has a value B. This is not capital A, not a character A. So here we need to write a failure 1. Failure occurs. So at cell number 4, we have got failure. Use the diagram. At cell number 4, fail of 4. Fail of 4 is pointing the cell number 2. Fail of 4 is pointing cell number 2. Fail of 4 is 2. So next cell number is 2. In case of failure, retain the text index and character as it is. Now check if cell number 2 character A. Cell number 2 character A, it's not character A, it's B. So again, we have got a failure 1. Then fail of 2. Fail of 2 from the diagrammatic representation, we need to move to cell number 1. Fail of 2. This is cell number 1. Text index is 6. Character is A. 1A. At cell number 1, character A is there. Yes. This is a success. Then cell number 1, right? This is changed to 2. Then 6A, 7th position. 7th position, we have a character B. So 7B. Check at cell number 2, we have a character B. At cell number 2S, we have a character B. It's correct. This is a success. Then cell number 2 becomes 3. Text index is 8. At 8th position, we have a character A. Now check if cell number 3 has a character A. Cell number 3, yes, cell number 3 has a character A. This is true. So again success. Next, cell number 4, text index is 9. Ninth index is right B. Writing B here. Check if cell number 4 has a character B. Cell number 4 has a character B. Success. Then cell number 5, text index is 10. The 10th character is capital A here. This is capital A. Check if cell number 5 has a character A. Cell number 5 has a character C. So at cell number 5, we have got a failure here. If there is a failure, right, find fail of 5. What is fail of 5? Fail of 5 is pointing to cell number 3. So next stage, fail of 5 pointing to cell number 3 here. Writing here, this is cell number 3. Text index 10, character A. Cell number 3, check if it has a character A. So cell number 3 is character A is available. So this is success. Then cell number becomes a 4. Text index is 11. 11, right? We are reaching the end of the text. So when j is greater than the end text, right, the function returns a value, a boolean value, right, a true, so that we need to terminate the process. At 11th index, right, there is no text character. In this case, success or failure, right, this is a failure 1 because the pattern length is m, pattern length is 6. We have not obtained 6 successful searches, right, continuously A, B, C, B, right. It means seeing this diagram or trace 1s, here 3s, 3 successful success. Then next, right, we have got failure. Then here yes, 4 successful success. Then only 1 success. We have not obtained the complete 6 successful success. So clearly the final result is failure. This indicates that the given pattern AB, CB is not available in the given text. The given pattern P, AB, CB is not available in the given text. So it seems AB, CB, right? So it partly, right, matches here. AB, that's all. 4 characters are matched. That's what here in that trace we have got these 4 successful searches AB corresponding to the text characters. We have not obtained completely the 6 successful searches as 6 aces continuously not obtained. That's what we are concluding, that the given pattern P is not available in the given text. So to check if the given pattern is available in the text, according to KMP, what we have to do, we need to first find the KMP flowchart construction. So we need to construct the KMP flowchart. Step number 1, we need to fill the successful links. Like this, we need to take the pattern characters as corresponding nodes. Nodes are numbered here. Successful links are filled. Then the second step, we need to trace the algorithm to find out the corresponding failure links for the range of k from 2 to m. After this construction, in step number 2, we need to fill the failure links in the diagrammatic representation. So updating step 1 here, update the failure links in step 1, we will get the equivalent of flowchart construction. So this flowchart or machine, this is simply used to text, or this is used to scan any of the given text t values. In this example, we have taken, for example, AC, AB, AA, BA, BA, so that the pattern is not available in the given text. In case if the pattern is, for example, AA, BA, BA, then we will be getting AA, BA, BA, right? 6 pattern characters. 6 successful searches will be obtained here, so that we can easily find the pattern is available in the given text. Finding the 6 successful searches, we need to mark here 6 successful searches, and finding where the first S is available corresponding to that text index, we can easily conclude the pattern is available in, or pattern starts at, that text index. So this way, the KMP flowchart construction or KMP flowchart helps us to check if the given pattern is completely available in the text or not. If it is available, it returns the index where the pattern is available, or where the pattern starts in the text array. In case if the pattern is not completely available, the given pattern is not present in the array, then finally the algorithm returns a failure search that indicates mismatch is found. The pattern is not available in the text t. This is the logic of a KMP flowchart construction, and the KMP flowchart construction helps to check if the given pattern P is available in the text array